Okay, before we start, can you please get confirmation that you guys can hear me and see my screen? Yes. Okay, perfect. So, thanks for I was slightly late. Nevertheless, let's continue. Okay, assalamu alaikum and good morning to one and all. Welcome back to grade 10 mathematics by Inspired Teens. So in today's lesson, we are going to be continuing equations and inequalities, exponents. So we're going to be doing exponents. Well, let's do exponents. Okay, perfect. Do we do questions? No. Not very many questions. We did some questions actually. Okay, so we need to finish up this. Let's see. What is this? Solving steps. Okay, denominator. Channel steps for solving quadratic equations. Okay, nonetheless, we probably won't start trigonometry today, but we'll get there eventually. So let's finish up. We're going to start off with linear inequalities and then move our way up. Okay, perfect. So, are you guys on holiday? Are you guys done with school? Are you guys done with exams? And are you guys currently on holiday? No. Okay. Are you guys still writing? Or have you written already? Or are you still writing? You're still gonna write? Okay, cool, perfect. Okay. That's fine. So linear inequalities, relationship between expressions that are not equal. Okay, we call these inequalities because they're not equal. Makes sense. So in inequality, let's look at some examples. If they say x and then that weird sign a, that means that x is greater than a. Okay, if they say x and then that weird sign upside down and then a, that means x is less than a. So what you need to remember is the open side. Okay. No, so not the pointy side. The pointy side is always less than. Maybe that's the easiest way to remember it if you forget it. The pointy side is always less than. Okay, and whichever side the open side is facing, that's the greater than sign. So this here could also be written as a is greater than x. Okay, which makes sense. If a is greater than x, then x is less than a. Okay, so similarly for these, we can say here x is greater than 2. Here we can say x is less than 2 or 2 is greater than x. Like obviously, normally we just read left to right. That makes most sense. Okay. So similarly for inequalities, we have a slightly different expression for them. By adding a line, okay, this just means that it could be equal to. So in this case, we would say x is greater than or equal to a just because of that extra line. Okay, we'll discuss it in terms of a number line in a second, and it will make more sense. Let's look at this interval notation, open intervals, close intervals. We'll describe that in a bit. But basically, here we have a to infinity, or negative a to infinity. Okay. Let's see. So I think what they've expressed is this here, okay, in interval form. Okay, we'll discuss it in a second. So if I'm going to say that x is greater than a, x is greater than a. So let's replace a with a number to make our lives easier. If I have to say x is greater than 3. So if x is greater than 3, x could be 4, x could be 5, x could be 17, x could be 200, x could be 7,000, x could be 300,000, x could be 6 million, x could be 17 billion, x could be anything up until positive infinity because I'm saying that it's greater than 3. So I can express it in terms of intervals, okay? How do I do that? I say x is an element of, okay? So instead of using these inequalities, I can use intervals. I can say x is an element of, and I use my brackets. We use circle and square brackets for different things. We'll discuss it in a bit. For now, we use both of these would use circle brackets. So my starting value, okay, if I consider when I say x is greater than 3, my starting value, my lowest value there would be 3. Okay, don't worry, I know, okay, we'll discuss it again just now. for the sake of this, let's just learn the interval. And my highest value in that case would be positive infinity, because like we discussed, right, when x is greater than 3, it can be any number that's greater than 3 up until positive infinity, because that satisfies that inequality. Okay, so x is an element of, so that's how we write it in interval form, starting value of 3 and ending value of positive infinity. Now, when I say x is greater than 3, x cannot be equal to 3 because it has to be greater than 3. Okay, so basically x cannot be 3, right? We're starting maybe from 3.1 if you're considering decimals. Okay, if you're considering only integers or whole numbers, you're starting at 4. X, you'd say 4, 5, 6, 7, 8, 9, 10. That's where your x should start from. So why are we starting off with 3 here? That's simply because this round bracket, okay, the round bracket indicates inclusion, meaning you are including, okay, and a square bracket, sorry, I am not that smart. A circle bracket means exclude, okay, and a square bracket means include. So what does it mean to exclude and include, right? Let's discuss it in terms of a few examples. Let me give you an interval and say that x is an element of 3 to 10. Let's do 8. X is an element of 3 to 8, but now you can see we have two different brackets. We have a circle bracket for 3 and we have a square bracket for 8. Okay, so let us discuss the numbers that fit in this interval. So firstly, because 3 is excluded, I do not start at 3, I would start at 4. Just say I'm considering, let's just say x is an element of integers. I'm only considering whole numbers. Okay, so x is an element of integers, so no decimals. So let's go 3.1, 3.2, 3 will be here till wherever. Okay, so 4, which numbers fit in this interval? 4, 5, 6, 7. Do I put 8? Yes, I do, because the square bracket says I should include 8. The reason I've excluded 3, even though it's written 3 in the interval, you would start at 4 because it excludes 3. So the values that fit within this interval are 4, 5, 6, 7, and 8. Let's do one more. Let's do x is an element of 2 to 7. Okay, so which values fit in this interval? I will start at 2 because 2 is included. 3, 4, 5, 6, 7. As many of you might have thought, you don't include 7 because it clearly says excluded. You stop at 6. Okay, so that's what the interval basically means, include, exclude. Okay, now that we're all caught up, we can understand. Okay, so another thing is that when we don't have the or equal to, basically this here follows the circle bracket, which is exclude. Let's maybe do this. Okay, and this means include. Okay, and it makes sense because in this case here, if we had to describe this in terms of an inequality, okay, we would say x is greater than 2, but it could be equal to 2 because of the include. So you would say x is greater than, can you see how the pointy side is away from x? So it means x is greater than whatever I'm going to write on the left. Okay, x is greater than or equal to 2, right? But x is definitely less than. Do I say or equal to 7? No, I don't, because again, it's a circle bracket. Circle bracket matches with the single inequality, not with the or equal to thing. So x is greater than or equal to 2, because it's included with the square bracket, but it's less than 7, not including 7. So again, this, what is that? The battery, right? So this here fulfills, these numbers fulfill the same interval, 2, 3, 4, 5, 6. Okay, so that's an interval notation. Okay, cool. So that's why when we have x is greater than 3, we don't include 3, it's excluded, and that's why we use a circle bracket. And when it comes to infinity, this is an exception. Infinity is always excluded. Okay, it makes sense because If you're going to include infinity, what exactly are you including? Are you including 5 million, 10 million, 6 billion, 1 trillion? You're including nothing. You can't include something that you don't know the value of. Okay, so then that's expressed in terms of intervals. So let's have a look at it in terms of number lines. Okay, so we have 2 and infinity. Okay, they want us to express the value of this interval 2 to infinity. Okay, so please type in chat, what would this be in an interval form? Sorry, this is the interval form. We'll say x is an element of. Okay, what would this be? How would you express this in terms of inequalities? How would that be expressed in terms of inequalities? Somebody tell me. If you guys are alive. Anyone? X is greater than 2, very good. Okay, because it's from 2 to infinity, so it's not, you don't include 2 because it's excluded there. So you'll say X is greater than 2. So when you say X is greater than 2, you are saying X is everything past 2, greater than 2, up until positive infinity, and that's exactly what this interval is saying. Okay, what about this here? This is the interval form. X is an element of negative infinity to 2. This is the interval form. How would this be expressed in inequalities? If we start at negative infinity and we end at 2, how would that be expressed in terms of the inequalities? Yeah. Okay, x is less than 2, very good, because x is less than 2. So when we think of x is less than 2, x is less than 2 would be everything smaller than 2, everything smaller than 2. So everything meaning up until infinity, but in the left direction, so negative infinity, because we go 1, 0, -1, -2, -3, -4, and so on, up until the negative infinity. Okay, and then when we express that on the number line, it's simple because we have 2, okay, which is the value we're working with. And then from 2 to infinity, you just simply start at 2, right? And draw a line going forever to the right to positive infinity. Now, why do they have this circle? Because this circle also indicates exclusion. So this means it's excluded. So this whole or circle means 2 is not in this interval. It's not included on this part of the number line. And then when we talk about starting at negative. So why do we write negative infinity first? Because that's the most left value. The most left value is, the smallest value here is negative infinity, and then the biggest value is 2. The start value is negative infinity, the end value is 2. In this case, you are going from 2 to negative infinity, okay? And this whole also means exclude, it means exclude, and yeah, it's going to negative infinity. Okay, let's look at it for closed intervals. So here it's the same thing, but when you include, so as you can see here, 2 is included and the circle dot represents including. Okay, so when you include on the number line, you'll put a full circle to indicate that that number is actually part of that interval. Okay, so I hope that makes sense with regards to include, exclude, interval, inequality, number line. Let's do some examples. I don't know. I don't think you guys are required to do number lines. Do you guys work with number lines? If, yes. Okay, that's fine. If 2 of you work, and I'm sure most of you do work with number lines. So let's discuss it. So in this case, they'll tell you to simplify the inequality, or yeah, basically they'll tell you to simplify the inequality. So here we just want to get x with respect to this inequality, right? You're not going to find the value for x, but you're going to say more or less what x could be. Okay, x could be greater than 5 or whatever it is. So the way we solve this is like normal algebra. Okay, and then we just work with the inequality. So in this case, I see 4 open brackets, 2x minus 1, I can distribute. Okay, so I will have 8x minus 4 is greater than 5x plus 2. Let me just notes. In sorry. There you go. Sorry. Okay. So now we just like how we solve an expression, algebraic expression, we are going to solve an inequality in the same way. Okay. So you want your variable on one side and your constant on another side. So I'm going to bring the 5x over, so it becomes minus 5x, still greater than, and I'm going to take the negative 4 over, it becomes positive 4, so it's 2 plus 4. Now in this case, I have like terms, so 8x minus 5x and 2 plus 4. 8x minus 5x is actually 3x. 3x is greater than 2 plus 4, which is 6. Now, again, I need to leave my thingy, the variable alone. So you can either take 6 over as a 3 over as a division, or if you say that you divide both sides by 3, whichever works. So x is greater than 6 divided by 3 is 2. So my final answer is x is greater than 2. That's my answer for x. Okay, if I have to express that on a number line, I will draw up my number line. Okay, whichever values I'm working with. 2 I draw in. If x is greater than 2, it's everything everything after 2 till positive infinity. If we have to, do we include or exclude? We exclude because the question excludes. So we draw an open circle to exclude and then a straight line to positive infinity. And that's how we'd express that x is greater than 2 on a number line. Let's have a look at this question, which was asked in November 2022. So the latest, go back to which part exactly? That's fine. Do you have it down? The notes will be sent to you guys afterwards, again, by the way, so you will have access to them if you missed anything in the notes. Okay, do you need to take down a note? Or just, okay. No problem. Let's continue. I'm going to start today, probably next week. Okay, so yes, let's have a look at this. So slightly more complicated. I have -1. So when you have a double inequality like this, okay, your inequality is going to be in the center. Okay, and you are going to try and leave your inequality alone in the center. Okay, so we have seen for now, for today, one example of this, a double inequality, right? Where we said that x is actually greater than 2 because it's sort of like between 2 and 7, right? But including 2, excluding 7. So it would, if in that case, if something's between two numbers, you would say it's greater than the smaller number, but smaller than the bigger number. Okay, which makes sense, right? So in this case, all we have to do is really simple, right? So the first question is to solve for x in the inequality. So that's how they'll phrase it. Solve for x in the inequality, where we have -1 is less than or equal to 1 minus 2x over 3. Okay, which is less than 5. So just like how in this example, we want to leave x alone. Okay, we want to leave x alone and take all the constants over, or take everything over. So too do we want to do in this example, right? In this example, what we want to do is we want to leave x alone, but not on the left or not on the right, in the center. Okay, so in the center, we have to analyze and ask ourselves, what is with x that we need to take over? The first thing is this 1. Okay, so this 1 is a positive 1. Okay, so when I take it over to any other side of the equation or inequality, it will become negative 1. So this is how we do it. So I'm going to get rid of the 1. So what am I left with? I'm left with there negative 2x over 3. Negative 2x over 3. These signs remain the same for now. Okay, and essentially what I do is I take the 1 and I subtract it from either side. So from the left, I subtract 1, sorry, from the right, and from the left, I subtract 1 as well. Both sides. So I take it to the right and I take it to the left, essentially. Okay, so I minus 1 from the left, minus 1 from the right. Let's simplify. 1 minus 1 minus 1, that's minus 2, less than or equal to negative, I'm just going to keep the negative with the top, it's easier that way, 2x over 3. Five minus 1 is actually 4. Now what else is attached to the x that I can take over? That would be the 3. Since it's in division, okay, negative 2x divided by 3, okay, I would need to take it over as multiplication. So I multiply, so I leave negative 2x in the middle, and I multiply each side by negative 3. So 4 times, not negative 3, sorry, this positive 3, and negative 2 times 3. Then I can simplify. So I'm left with negative 2x. This is 12. This is negative 6. Okay. Now, what's the last thing that's attached to the x? That would be the negative 2. So essentially, I need to take the negative 2 over to each side. So I need to, because it's negative 2 times x, when I take it over to the other side of the inequalities, I would say divided by negative 2. Now, there's one thing that's very important in this section. When you divide or multiply, only for dividing or multiplying, when dividing or multiplying, by a negative, the inequalities need to be reversed or flipped. Okay, I'll explain it in a second. Okay, so what does that mean? So in this case, we are in that scenario, right? Because now I have to take this negative 2 over and I have to divide it on each side. So I'm dividing by a negative. Okay, so you'll see what I need to do is when I divide by a negative, so as you can see, I have x here, right? I have x there, and because I know I'm taking negative 2, I'm dividing by a negative, I will reverse my inequalities. So this less than actually becomes a greater than, and then this greater than actually becomes a less, the greater than or equal to becomes a less than or equal to. Okay, I hope that makes sense. Then I'm going to have 12, okay, times negative 1, sorry, negative 2, and I'm going to have negative 6 times negative 2. When I simplify this, I get x is greater than negative 24, but it is less than negative 12. So you see, it makes sense, right? When I flip it, x can be, if you want to consider something greater than negative 24, but less than 12, that's a possibility. So what I mean is, let's just say we didn't, we forgot this step, right? We still kept it like this, the other way around, okay? it says here that x is greater than negative 12, but less than negative 24. That doesn't make sense. Oh yeah, sorry. Positive 12. Okay. So here it says x is greater than 12. So what's greater than 12? 13, 14, 15. Okay. However, it says that it's less than negative 24, not negative 25, negative 26. How can it fulfill both of these criteria? Like, it doesn't make sense at all. So if you forget to flip it, that's what it's going to look like, and it's not going to make sense. Okay, sorry, yeah, here we have a negative times a negative, which gives us a positive 12. Okay, so here we have to flip it. We make sure we flip them. Okay, so it's going to be x is greater than negative 24, but less than 12. So it could even be written this way: negative 24, x is greater than negative 24, but less than or equal to positive 12, which that makes sense because it's less than greater than negative 24, so negative 23, negative 22 up until where? Less than or equal to 12, so up until 12. Gosh darn it, yes, you're correct. Someone says once you're supposed to divide it. Yes, I was supposed to divide it, so let's change that. Okay, so the reason I was supposed to divide it was because it was multiplication here. There's negative 2 times x. Yeah, I'll need to say divided by negative 2. Choose brackets. Divided by negative 2. So when I divide it, here I get negative 6, and here I get negative 3. Right? I think that's correct now. So negative 6, negative 3. So x is greater than negative 6, but less than or equal to negative 3. Positive 3. Oh, life is hard. Correct. Sorry for the 7 billion mistakes. But yeah, I hope the concept is there. I was just testing to see if you guys were awake anyway. Okay. So x is greater than negative 6. Okay, but less than or equal to negative 3. Is everything correct? Please double check. Everything's correct. Okay. But yes, let's just revise one more time what we do. Okay. We took the 1 over. The 1 is a positive 1. So when we take it to each side, it becomes minus 1. Okay. Then we left with negative 2x over 3. There's nothing wrong with having the smart steps in the exam as long as you're decent with your speed. And if it makes sense to you, it makes sense to you. Don't try and skip out steps if you're going to get the question wrong. Okay. So then negative 2x over 3. Then the 3 was attached to it. Okay. So what we did with the 3 was we took it over. It was attached as a division. So we took it over as multiplication. So we multiplied everything by 3. We got negative 6 and positive 12. Then we were left with this negative 2. So we had to divide everything by negative 2 on either side. Divide by negative 2, divide by negative 2. We got that and we got that. And then this is just rearranged if you'd like to write it like that. Then we need to remember when dividing or multiplying by a negative only. Some people get confused, like when do you do this? When do you flip signs? Not when you're adding, no, sorry, not when you're just subtracting. No, when dividing or multiplying by a negative. Now, some people think when it's only when you multiply, but it's also when you divide. Some people think when it's only when you divide, but it's also when you multiply. It's not important to rearrange it. I just feel like maybe some people will understand it more like that. If the interval like would make more sense this way, because you can clearly see that x is greater than negative 6, but less than 3. But here the bigger number, sorry, the smaller number is on the right. That's why rearranging it. It's not so important. But yeah, you can leave your final answer like this, no problemo. That's okay. Okay. So yes, it's when you divide or multiply by a negative. It doesn't have to be also, by the way, it doesn't have to be 2 inequalities for that to be true. Even if it's a single inequality, even if I have negative 2x is greater than or equal to 6, okay? In this case, I have to take negative 2 over. This would have to flip, and then it would become divided by negative 2. Okay? When you divide, I'm taking this over as division. Yeah, division. Okay, so inequalities, right? Let us express this one on our number line. So basically we are expressing this interval. We'll do two things, right? We'll give it an interval notation. This is inequality, and then we'll do it on the number line. So let's do number line and then we can do interval. So number line, you have to put the two values that we're working with. So -6 and +3. Obviously +3 is to the right of that. Now, whenever you have an inequality like this, okay, that generally means that your variable is between your two numbers. Okay, so your thingy, your line is going to be between these two numbers, somewhat like that. Now the thing for you to decide is, are you going to include or are you going to exclude? That's really simple. As you can see, this does not have the or equal to, so this one excludes, and then this one has the or equal to, so this one includes. Very nice. Okay, so for -6, I'm going to have a circle that's empty, and for 3, I'm going to have a circle that's filled in, and that tells me I have to include 3 but exclude 6, and I connect them to show that x is anything between these two values. Okay, let's pretend that that is straight. So that's that expressed in terms of a number line. Let's talk about interval notation. I could say x is an element of -6 is my starting value, 3 is my ending value, -6 is excluded, 3 is included. Okay, cool. I hope that makes sense. Let us move on. Okay, linear equations. So this is just a revision of linear equations. We just did linear inequalities. So it would be very similar, except this has an equation. Obviously, it has an equal to sign. Move all the variables to one side and the constant to the other side on order. On order to solve the equation. Linear equations have only one solution. Okay, this is baby work. So here I have a bunch of brackets which require distribution. I'm going to distribute all of them actually. So 4 times 2p is actually 8p. 4 times -7 is actually -28. -8 times 5 is -40. -8 times -p is +8p. Are you guys following? Okay, please tell me that you are. 3 times 2p is 6p, and 3 times 4 is 12. -5 times p is -5p. -5 times +7, that would give us -35. So now I'm going to take all my variables onto one side. So I have 8p already here. I have plus another 8p, which is already there. Then I have 6p and -5p. So 6p comes over as -6p. 5p goes over, -5p goes over as +5p. Okay, that's about all of them. On the right hand side, I already have 12 and -35, so I can write them on the right hand side. +12 minus 35. I take -40 over, I take that over, they both become positive. So plus 40 plus 28. Okay, sure, you can solve it on your own. I'll give you guys like a minute. I know you're already like halfway in, but I guess continue where we left off. Sorry, I didn't see your message a second earlier. Just indicate when you guys are done. Okay, so let's solve it. You guys got 3. So 8p plus 8p, that's 16, minus 6 is 10, plus 5 is 15p. Negative 35 and plus 40, that's positive 5. Positive 5 and 12 is 17. 17 and 28, that would be 35 plus 20, so it should be 55. 55 or 45? 45, maybe. Yeah, definitely 45. And then we get 3. That should be correct. Let's double check. Okay, so yes, we get p is equal to 3. So that's linear equations. That's nothing new, nothing fancy. Like, you guys should all be able to solve these, right? Just revision. Let's talk about literal equations, which is not just only good for this. If you guys do physics, this is excellent for physics. Okay, physics, chemistry, finance. This is going to help you in finance, in mathematics. Okay, literal equation. So it makes it says make a specific variable the subject of the equation. Why do we only have one example? Okay, nevertheless. So we have example, the surface area of a cylinder is given by A is equal to that. Okay, it's given as A is equal to 2 pi r, okay, open brackets H plus R. Okay, so they want us to, okay, they say prove H is equal to blah blah blah. We don't know about that. They just want us to leave H alone. Let's just make our life simple. Leave H alone. That's informal. Make H the subject of the formula. That's formal. And again, it just basically means for you to leave H alone. Okay, so currently the subject of the formula is what? What is the subject of this formula? What is the subject of this formula? What's left alone? Which variable is left alone? Okay, correct. Anyone else? A. Okay, good. A, right? A is the subject of this formula, meaning A is the one that's left alone. A is the variable left alone. So we want R to be alone. So we know, that's why we take revision of linear equations, because remember, when we take over to the other side of the equation, we do the inverse operation, meaning if it's plus, if you want to take it, if it's plus on the left and we want to take it to the right, we minus. If it's multiplication, we divide. If it's division, we multiply. If it's addition, we subtract. If it's subtraction, we add. Okay, so now, as you can see, right, this 2 times pi times r is multiplied into the bracket of H plus R. Now, this 2 pi r, you don't have to take each one over. You don't have to say A over 2 is equal to pi times r, H plus R. And you say A over pi 2 is equal to R. You can take them all over at once. Okay, because when they're all in multiplication, it's like they are one term almost, okay, because they're going to give you a certain value. So you can take them all over. These are all in multiplication with H plus R. So you take them over, it becomes A over 2 pi R is equal to, now we can get rid of the brackets because there's nothing multiplied to it, H plus R. So now it's even easier. To leave H alone, we just take, or we can take R over as a subtraction. Okay, so it becomes A over 2 pi R minus R, because we take it over as minus, is equal to H. If we want to write it as one term, that's really simple. Okay, if you want to express, so H is already left alone. We have made H the subject of the formula. If you want to write your left-hand side as one term, you can basically do LCD, lowest common denominator, where the lowest common denominator is definitely going to be 2 pi R, because Why? Because R is 1, and the lowest common denominator between 1 and anything is that thing. So let's paste this here. We can write R as R over 1, because that's what you do when you do LCD. You want to write everything as a fraction. So now the lowest common denominator is going to be 2 pi R. So we multiplied 1 by 2 pi R. So what you do to the bottom, you do to the top. So you multiply the top by 2 pi R as well. And now you're going to have everything essentially over the same denominator, which is 2 pi R. You're going to have A. You keep the minus sign, minus, and you're going to have, okay, let's do it step by step. You're going to have A over 2 pi R minus R times 2 pi R over 2 pi R. Now, please don't go and cancel that, because then you're just going to get back to what you had. Okay, this is equal to H. I'm going to take H to the left side and then everything to the right side. It doesn't change anything. It's just easier to understand that way. Now, because my denominators are the same, okay, I can express everything under one denominator. If I write it under one denominator, I have 2 pi R. Okay, and then I write each term. Okay, I have A. I keep the sign as minus 2 pi R times R is basically 2 pi R squared, variable times a variable, 2 pi R squared. So now I've completely left H alone and expressed the other side as one term, A minus 2 pi R squared over 2 pi R. Can you distribute 2 pi R into the brackets? You may do that, although it's going to make your life a bit complicated for no reason. So A is equal to, that's why, okay, you can do that, but you just need to get smart about it, honestly. Like, don't be doing things that's going to make your life harder. Okay, you're allowed to be lazy in maths, provided that being lazy in the right way. Okay, so if you're going to multiply it out, like, let's do it, right? So maybe it's a bit, let's see, 2 pi R times H plus 2 pi R squared. Okay, then we can take A minus, okay, again, I want to leave, my objective is to leave which guy alone? H. I want to leave H alone. So what's attached to H? Of course, this multiplication of 2 pi R is attached to it with multiplication. So I take the plus over, it becomes A minus 2 pi R squared is equal to 2 pi R times H, which is what I want to leave alone ultimately. Okay, so now what I want to do is I want to write the term with H on the left already. So I don't have to change the signs here, just because I haven't changed the value of anything. I'm just like, I basically what I did is A is equal to B, right? Okay, then B is also equal to A. It's the same thing, right? I just wrote A on one side and on the other side. Okay, so now in order to leave H alone, I just have to take this over as division. Okay, but I don't divide it by just A or just that, I divide it by the whole thing. Okay, so H is equal to A minus 2 pi R squared divided by 2 pi R. Why be divided by 2 pi R? It's like I divided both sides by 2 pi R to get rid of it. So like here, 2 pi R cancels, and then 2 pi R, because what you do on the left, you must do on the right. And that's how we end up with that. So A is equal to, H is equal to A minus 2 pi R squared over 2 pi R. Okay, so in this case, actually, that's a faster way. All right. But generally, distributing is not always faster. Okay, so just be careful. You get used to it, right? If we do a bunch of little equations, let's see if I can find one more example for us to do. Yeah, let's maybe do a complicated one like this. 3x plus 1 divided by 2x minus 1 is equal to 5y plus 1 divided by 2y. All right. So here they want us to leave y alone. Okay. So the way we're going to do that again is because we want to ultimately get our variables for y on one side, okay, and then the ones for x on another side. Whenever you have two variables, so sorry, whenever you have just say your variable that you want to leave alone, okay, you always want to do what? You always want to group them on one side. Okay, so we'll try and do that. So the first thing we can do to, wait, let's just think about this. That might be a bit too complicated. Okay, it's fine nevertheless. Right, let's do it. It is a bit complicated, but I think the best way to do this is actually the long way. It's to multiply out the bracket. So I'm going to cross multiply, and you'll see in the end why we do it, right? I'll explain it. So I'm going to have 2y open brackets 3x plus 1 is equal to 5y plus 1, okay, times 2x minus 1. Okay, so cross multiplication, multiplying this with that, multiplying that with that. Okay, now I'm going to open up my brackets. So here I will have, here I will have 6xy. Okay, I'm multiplying 2y times 3x, and 2y plus times 1, which is basically 2y, is equal to, I'll FOIL this side out, so 5, no, first outer inner last, first outer inner last. So first terms I multiply, I will have 10xy, okay, outer terms f5y and negative 1, that becomes negative 5y. Inner terms 1 and 2x, that becomes positive 2x, and last terms positive 1 and negative 1, that becomes negative 1. Okay, so what you want to do is you want to take all your terms with x, all your terms with y, doesn't matter what's attached to them, all your terms with y, and you want to take them over to one side. So let's take them over to the left, 6xy plus 2y, okay, minus 10xy plus 5y, minus 10xy plus 5y. This is going to be equal to whatever's left, 2x minus 1. So I've grouped all my terms with y. Okay, I can actually simplify it one more. So I'm going to do that just because it's like terms. It can actually be simplified to 6xy plus 7. Oh, it can be simplified a lot, actually. Sorry, I didn't realize that we have multiple like terms. So multiple like terms, of course, we have the like terms here, 6xy, negative 10xy, 2y, and 5y. Okay, in that case, let us do the simplification. So it becomes, you should take it out, but it's fine, never mind, negative 4xy, okay, plus 7y is equal to 2x minus 1. Again, keeping our y's one side. Now we can finally do what we've been setting up to do the whole time, and that is actually to take a common factor. Can you do FOIL for the second part? Yeah, sorry, I don't know at what point you asked that question, before I FOILed or after I FOILed, but that's what we did. Okay, so you always want to leave your y terms alone, no matter how many terms. You can have 3, 4 terms on the left, 1 term on the right, it doesn't really matter. You just want to always leave your term, the variable that you want to leave alone. You leave all those terms on one side, so you eventually can take a common factor. Okay, that's the objective. So what's my common factor here? Of course, it's the variable we want to leave alone. That's going to be y. Okay, when I take out y as a common factor, which is brilliant because now y is alone, okay, I'm left with negative 4x plus 7. If you guys agree with that, negative 4x plus 7. This is equal to 2x minus 1. Right? Now, when you take that common factor, you actually create a multiplication with whatever's in the bracket. So you can simply leave it alone by leaving it alone and taking the other side over as division. So y is going to be equal to, so it's like you're dividing both sides by this guy, negative 4x plus 7, negative 4x plus 7. This cancels with that. And on the right hand side, you're left with 2x minus 1 divided by negative 4x plus 7. And that's in its simplest form, and that's y is equal to that. Provided that there are no no calculation errors, that should be correct. Yeah, if you'd like to have your negative in front of your bracket, someone's asking, can you take the minus sign as an HCF by the, you sure you could. So you'd have 2x minus 1 okay, negative 4x minus 7. This negative sign could actually move there, it doesn't really matter. You could have that if you'd like. Depending on the question, it's not too finicky. And that's your final answer, correct. So your objective is not to solve for anything here. Your objective is not to solve for anything. Your objective is to just leave your variable alone. That's it. So whatever it's expressed in terms, it can be expressed in terms of 10 other variables, however many other variables. It's not to solve and find a value for that certain variable. It's just to leave it alone and express it in terms of everything else. So that's another example. That's potentially difficult. But yeah, some require some extra skills, like maybe you have to factorize in some. You just have to try your best to leave it alone. Remember common factors. This is a key one, right? When you have multiple terms with that variable you want to leave alone, common factor is a good way to leave it alone. Okay, so let's end it there, and then next time we will do quadratic equations by factorizing and move on to whatever's next, and then eventually trigonometry. Okay, cool. Good luck, guys. All the best for exams, for those who are writing and other things. Have a good week at school, and I will see you guys next week. Okay, same time, same place. Thank you, guys. Jazakallah khair. Yeah, you may ask me on WhatsApp. Sure, just message me. Okay, Jazakallah khair. Assalamu alaikum and